In our next unit, which is Unit 9, and we're going to work on solving the quadratic equation, which is an equation in this form: ax squared plus bx plus c equals 0. And I'm going to show you several methods for solving this. And so let's begin with the graphing method. All right, so this is the first lesson on section 9.1, solving by graphing. Let me reduce this down a little bit in size. There we go. And please pause your video at this time and write down the information that you see. All right, so again, we're solving this quadratic equation, and in the place of a, b, and c will be numbers. X is the variable in this quadratic equation. And solving this equation means that we're finding the values of x that will make this a true equation. In other words, it will be equal to 0 after we substitute in the x that we find. All right, so we have actually already learned one method for doing this, and that is called the zero product property method. Essentially, it's the idea that if we can get an equation on the left to be in factored form, a times b, and that is equal to 0, then one of those factors, either a or b, will be equal to 0. So just as a quick reminder of that method, here's a quadratic function that is set equal to 0, and I'm going to factor this into two binomials. All right, so the two binomials would be x minus 2 and x plus 4. All right, and so just to remind you of where I got that from, I factored the x squared into x times x. I factored negative 8 into negative 2 and positive 4, and I chose that because the sum of the like terms, negative 2x, and this product here, positive 4x, if I add those together, I get the middle term, positive 2x. So there's my factored form. And now I have two binomials. This is a product of two binomials. So one of those two binomials must be equal to 0. So the next step would be to say x minus 2 equals 0, or x plus 4 equals 0. And then I solve each of those equations. Of course, I add 2 to both sides on this one, and so that gives me a solution of x equals 2. On this one, I would subtract 4 from both sides, giving me a solution of x equals negative 4. So those are the two possible values that make the original quadratic equation equal to 0. Do a quick mental check. Let's plug in 2. Let's see what happens. 2 squared is 4, plus 2 times 2, which is also 4. So we have 4 plus 4. That's 8. Subtract 8 from that, we get 0. Check. All right, how about negative 4? A little harder because it's negative, but let's do the mental math. Negative 4, if we square it, is positive 16. This is 2 times negative 4, which is negative 8. So 16 minus 8 is 8. And now subtract 8 from that, and we get 0 again. So those two solutions work, all right? So just a quick review of that. But today we're going to focus on the method called the graphing method. In the last unit, you learned how to graph quadratic functions. So we're going to use that to find the solutions to this. And the steps that we need for doing this are twofold. Step 1 is that we're going to graph the equation, the function in standard form. So it looks like this. We're going to graph y equals x squared plus bx plus c. All right, so essentially all I've done is where I have this equals 0, I replace it with a y. It has to be in standard form, so that means that I do need all of the values to be on one side of the equation in order to do the graphing. And I replace this part right here with a y, and that gives me this quadratic function. All right, so step 2. In step 2, after we've graphed that, we locate the x-intercepts. All right, x-intercepts are the location of they're points on the graph where y is equal to 0. So just as a reminder, it's points with the y-coordinate equal to 0. All right, and ordered points on the x-axis. Okay, so whatever it takes for you to remember that, we're locating the x-intercepts. So essentially the idea is that we're plugging in 0 for the y value, which is what we're starting with in the original quadratic equation. So we graph the function, and then we locate the points where y is equal to 0. Those are our x-intercepts, and those will be our solutions. Okay, all right, so there are different cases for the graphs of a quadratic function and the locations of their x-intercept. In fact, there are 3 cases. So case 1 is, I'm just going to draw a very short graph in case 1. And let me use another color. If I draw a quadratic function, I'm just going to sketch it. Just want the vertex to be below the x-axis, but it's opening up. And you can see that it crosses the x-axis in 2 places. So there's 2 x-intercepts. Well, that means that there are 2 solutions. All right, another case, case 2. Okay, quick little graph. Might have something where the parabola has a vertex that sits on the x-axis. So maybe a parabola that opens down or up, but in this case it's opening down. It crosses the x-axis at exactly 1 point. So this has exactly 1 solution. And so far we have two x-intercepts, 2 solutions. It sits on the x-axis, so there's only 1 point on the graph that is an x-intercept, so there's only 1 solution to the quadratic equation. And the third case, okay, so I'll draw axes, x and y axis. And in this case, the function doesn't touch the x-axis at all. It will never cross the x-axis. So here would be a situation, let's say the vertex is above the x-axis and it opens up. So because it's opening up, it will never go down and cross the x-axis. So in this case, there are no solutions to the quadratic equation because the graph never crosses the x-axis. So again, we're looking for locations of where the graph crosses the x-axis. All right, 2 solutions possible, crosses in 2 places. 1 solution crosses the x-axis at the vertex. No solutions, the parabola just sort of floats above, or perhaps is just floating down below, but will never cross that x-axis. Okay? All right, so we're going to do a little review on graphing quadratic equations or quadratic functions as we go through this process, so good review coming up. All right, so our examples are solving by graphing, okay, and our first example is the equation x squared minus 2x plus 1 equals 0. Again, I'm not going to try to factor that or any other method. I'm just going to try and graph that. So I start with, in step 1, I'm going to do a rewrite and write it as a function. Okay, so I have all the terms on the left side with an equal 0. So that means I just replace this with a y, and I get y equals x squared minus 2x plus 1. And this is what we're going to graph. All right, just as a reminder, to graph that, I need the vertex. So I'm going to use my vertex formula. X is equal to, that's the x coordinate, is equal to negative b, or negative 1 times b divided by 2a. And remember what your a, b, and c are. So we have in front is the a, so that's the a, is the 1 in front. And b is the number next to the x term, so this is b, and c is the last term, a, b, c. So plugging in those numbers, for b is a negative 2, so I have a negative 1 times the negative 2. And I'm dividing that by twice a, twice 2 times 1. And then I calculate that value, so that gives me x equals negative 1 times negative 2, well that's positive 2. And 2 times 1 on the bottom, that's 2. 2 over 2 is 1. All right, recall how we get the y coordinate, so that's the x coordinate of the vertex. All right, the y coordinate is by plugging into the quadratic function. So I get y is equal to 1 times x squared, or 1 squared, minus 2 times my x value, minus 2 times 1, and then plus 1. And then calculate that. So y is equal to 1 minus 2 plus 1. And that gives me negative 1 plus 1, which is 0. And so my ordered pair is, for my vertex, is 1 for the x coordinate and 0 for the y. Okay, now the only other thing I need is another point for symmetry. So an easy point to plug in, so like an extra point. Let me put that down here. Okay, good one to plug in, since I don't have the y-intercept, just to figure out what the y-intercept is. So I let x be 0 and plug it back into the function. So 0 minus 2 times 0 plus 1. Well, all the x's would get zeroed out, so that's just 0 plus 1. So my y-coordinate is 1. All right, and so calculate that. You can make a table of values, and don't forget that parabolas are symmetric, so we're going to use that to our advantage. Okay, I'm going to draw this out. Here's my y-axis and my x-axis. All right, the vertex is at 1, 0. So I plot that point. I get an extra point at 0, 1, which is right here. Okay, so the vertex is here and the extra point is here, so I can see it's going to open up. Don't forget to use symmetry. Your axis of symmetry goes through your vertex, so think of that as your mirror. So this point has a matching point on the other side. There it is. If you want additional points, you could plug in, let's see, that's x equals 2, so x equals 3 perhaps, and get that value. 3 squared, let's see if we can do that with mental math. 3 squared, that's 9. Minus 2 times 3, well that's 6, so 9 minus 6, that's 3, and then add 1 is 4, so 3, 4, so 3, 1, 2, 3, 4, and so here's my extra point, and again I use symmetry to cross over the axis, so this is 2 away, so I go a distance of 2 in the other direction, so it's balanced across there, so you can see the parabola taking shape. Alright, so let me connect that up. All right, so the solution to this quadratic, the original quadratic equation, is found by looking for the x-intercepts of this graph, and that's right here. So it turns out the vertex is the x-intercept. So let me make sure I'm pointing, clearly pointing. I'm going to use a different color. So right here, that's my x-intercept. That's what we're looking for. So that is my solution. What is the value of the x right there? It's the vertex x-coordinate. So it's x equals 1. So my solution to the original problem is x equals 1. Let's plug it in. 1 squared minus 2 times 1, so 1 minus 2 plus 1. Yep, that's equal to 0, which we already knew that because that's when y is equal to 0. Okay, so the solution, and there's only one, is x equals 1. All right, let's try another example. Excuse me. All right, so maybe we'll get a little faster at this. All right, we're going to find the solution to x squared plus 4x equals 0. Again, I want to write this. Our first step is to write it as a quadratic function. So I make sure that I have 0 on one side, and then I replace the 0 with the letter y, so I get y equals this. So rewriting. All right, and then I identify my vertex. I'm going to use the vertex formula. So I'll just write V for vertex, save a little space. And so my x-coordinate is, all right, let's locate A, B, and C. So A is 1, B, so that's my A, B is 4, and C is 0, right? We don't use C in the vertex formula, but just to kind of get in the habit of locating C. All right, so let's plug it in. We have -1 times the value of B, which is 4, and then we divide by 2 times A, 2 times 1. And that number is -4 over 2, which is -2. All right, that's the x-coordinate. Let's plug in and get the y-coordinate. Plug it into this function. So the y value is -2 squared. All right, we square the x. Then add 4 times the x, plus 4 times -2. All right, so that's 4, positive 4, and then this product is -8, so 4 minus 8, and that gives us -4. So the vertex is located at -2 for the x, -4 for the y. All right, we do need an extra point for graphing. And if I can plug in 0 for my x, I will. Since I haven't found that value, this is going to give me my y-intercept. And so let's use 0, plug in 0. And so the y would be equal to 0 squared plus 4 times 0. Well, that's just 0. So 0, 0 is an extra point. All right, let's see what we have. I can see I'm going to need some negative values. So I might want to make my x-axis up a little higher so I can go down to -4. All right, so here's my y-axis. And then I'm going to make my x-axis up a little higher. Okay, and so here's the y, and here's the x-axis. All right, let's plot our 2 points. Start with the vertex. -2, -4. 2, 3, 4, right there. Vertex. And an extra point is 0, 0, right there. All right, locate your axis of symmetry so that you can get that parabola shape. All right, this has to have a matching point on the other side. So since it's 2 squares away from the axis, I go 2 squares to the left. And there's my symmetry. So let's go ahead and construct it. Again, I was lucky here because those 2 points are right on the x-axis, and that's what I'm looking for. If you start plotting points and they're not on the x-axis, you have to keep going, plotting extra points, you know, and so how do you do that? You essentially just make a table of values and get x and y values that will make it work. So for this one, I have two. I have the vertex one. I have 0, 0, but I would keep going, maybe plotting 1, plugging in 1, and getting another value until I cross that x-axis. Okay, so I got lucky, and I've got 2 points. So it turns out those are my solutions. So the first x-intercept is when x is equal to, let's count, -1, -2, -3, -4. So x equals -4. And then this one right here is my other solution, and that is right on the, it's at the origin, so that's when x is equal to 0. So what are the solutions to the original quadratic equation? X squared plus 4x equals 0. The solutions are x equals -4 and or x equals 0. We say or, so there's 2 possible solutions. Okay, I'm going to give one more example. So if you don't have enough space, just go to the next page. I know I kind of I'm squishing this in. All right, my last one. Negative x squared is equal to 2x plus 2. Oops, sorry. Got to make sure you can see that. All right, so here is my last one. Let me draw lines to separate my examples. All right, this one's not in standard form, so I do have a real problem because the x squared is separated from the other terms, so I need to have 0 out one side. It might be easier just to move the x squared over, so I think I'm going to do that. Okay, so I'm going to take this term. I want to 0 out this side. That means I'm going to add x squared to both sides, but essentially that means that I'm going to get a positive x squared here, and since it's the x squared term, I'm going to put it first. So when I rewrite this, I get 0 equals x squared plus 2x plus 2. All right, so that's just a quick way to rewrite equations and move terms around. Just want to make sure you change the sign of the term on the side it's on to move it to the other side. All right, so now it's positive. All right, so remember that we rewrite this as a function that we're going to graph. So I'm going to put a y here where the 0 is. So y equals x squared plus 2x plus 2. And now I calculate the vertex. All right, negative b, so the x coordinate is negative of this number, -1 times that, so -2 over the twice a, and a is a 1, so 2 times 1, which is 2, and this reduces to -1. And I plug it into this function here and get the y coordinate. So y is equal to, all right, -1 squared, well, that's +1, plus 2 times -1, that's -2, adding 2. All right, that gives me a total of, well, 2 and -2 is 0, and added to 1 gives me 1. So my vertex is located at -1, comma 1. I'm going to see if I can fit it all. All right, and then I'm going to find the extra point. I'm going to plug in 0. Okay, so an extra point, 0, comma, let's see what happens. So my function's up here. If I plug in 0, I 0 out all the x's. 0 here, plus 0, plus 2. Well, that's 2, so 0, comma 2. I'm going to graph both of those. X-axis, y-axis. All right, let's see what this looks like. -1, comma 1. It's right here. 0, comma 2, 1, 2. I'm going to use symmetry, put the axis of symmetry through the vertex. Okay, that was my vertex right here. So symmetry, this point has to be matched across 1 unit across. So here is my parabola. And since the parabola is sort of floating above the x-axis and it's pointed up, it's never going to cross back down. It's never going to cross the x-axis. So this means that the original function, the original equation, has no solutions. It's as easy as that. All right, it is time for you to practice. So I wish you luck and come see me if you need help.